Hello and welcome. Today we're going to be looking at the unit test on differential equations, one of the topics in AP Calculus. As always, we're going to be going through all of these questions to help you understand how to approach and solve these questions in differential equations. If you like these videos and find them informative, please be sure to like and subscribe. And with that, let's get started on our first question. All right, we're going to solve this equation. dy dx equals xy squared over 8 plus y squared. Okay, so the differential equations we deal with in calculus are called, in AP Calculus, A, B, and BC, are called separable differential equations, right? The ones that you can separate out, you can separate them, the two variables, x and y, out from each other. So what we're going to do here is we are going to do that. We're going to separate them out. All right, so how do we think we're going to approach that? How do we think we can do that? Well, let's see. All right, so if we want to separate out the y variable from the x variable, well, we see that we can divide both sides by y. We can divide the right side and both sides really by y squared. Okay, so we have dy dx equals xy squared over 8 plus y squared. And now we're going to divide both sides by y squared. And for the measure, we'll multiply both sides by dx as well. So multiply both sides by dx, divide both sides by y squared. Get this is what you get. Okay, that's what you get. So dy over y squared equals x squared over 8 plus 1, which is what you got when you divide by y squared, times the dx, times this dx right there. Right, so now we just take the antiderivative of both sides. The antiderivative of 1 over y squared is going to be it's going to be what? Negative y to the negative 1. Yeah, that's going to equal let's see, x cubed over 24, right? X cubed over 3 divided by 8 then, plus the x plus c, right? Because you have to have that plus c in there. All right. So then what? Well, we're trying to make this equal to just y, not y to the negative 1 or something. So we multiply both sides by y. Multiply both sides by negative 1. You get y to the negative 1 equals negative x cubed over 24 plus x plus c, and then you get y. We're gonna take the reciprocal of both sides. So you get y equals 1 over negative x cubed over 24 plus x plus c. We're going to multiply both sides by 24, and you get 24 over negative x cubed plus 24x plus some constant, right? The constant doesn't really change, it's just anything, plus 24x. So we get that y equals 24 over negative x cubed plus 24x. Hold up. So negative, so one thing we forgot to put in there is that when you multiply by negative 1, you multiply everything by negative 1. So that gives you y equals 24 over negative x cubed minus 24x plus c. So we can take a negative out, and we get negative 24 over x cubed plus 24x plus the c, since the c doesn't really care what sign it is, it's just a constant, which is choice D. And we can keep going. Alright, Tess tried to solve the differential equation dy dx equals 2xy minus 6x. This is her work. Alright, so she separated out y minus 3. Okay, that's good. Step 2, divided by the y minus 3, left the dx, that's also good. Then ln y minus 3, x squared plus c1, that also works. We'll go both sides to the e. Wait a second. She raised both sides to the e, but she only raised the x squared to the e. She didn't raise the constant to the e. You have to do that. Alright, you have to raise the constant to the e as well. That doesn't, you can't just leave it behind. Okay, so when you raise that to the e and you get the y minus 3, absolute value of y minus 3, that's supposed to equal e to the x squared plus c1. The c1's supposed to be in the x, e to the x something. So this is where it got messed up, right? Right here, step 4. This is good. And then raise it to the e, but you forgot this part, so this is where it got messed up. Step 4 is where it got messed up. Alright, step 4 should be that. Right? You should put the c1 in the e to something. Alright, and we can keep going. dy dx equals 6x, and y2 equals 8. We're trying to find y4 now. Well, if dy dx equals 6x, that means that dy equals 6x dx, so y is going to equal 3x squared plus c. Right, so 3x squared plus c, that's it. Now, if we plug in 2, you get 8 equals 12 minus c, so c has to be negative 4, so you have 3x squared minus 4. 3x squared is going to be, if x is 4, that's going to be 16 times 3 is 48, minus the 4 is going to be 44. And we can move on. In this differential equation, we solve using separation of variables. Let's think about that. Can't. Seems we might be able to. Alright, what if we divided both sides by the square root of y? Alright, if we divided both sides by the square root of y, because we can write this as square root of 3x plus 5 times the square root of y. Right, we can write it that way. Right? Now, if we can divide the square root of y out by both sides, and you can solve it using separation of variables. And we can move on. Which slope is generated by x plus y minus 2? Let's see. So, whenever we have at x plus y equals 2, then it should be a 0, right? So it should be a flat line whenever x plus y equals 2. So x plus y equals 2 right there, right there, right there, right there, right there. Okay, so that's all flat. Flat, 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 flat. Here it's not flat, so that's incorrect. B could be correct. For this, right, you have right here it's supposed to be here it's supposed to be flat, here it's supposed to be flat, here, it's not flat anywhere. Any of those places. And then here, it's supposed to be flat there, and there, and there, and there, and there. Again, it doesn't do it. Here it's supposed to be flat there, and there, and there, and there, and there, and there. Right, so that doesn't work, so our answer has to be B. It's the only one that x plus y minus 2 is, when x plus y is 2, it gives you a 0. Alright, so that's our answer, and we can move on. Is y equals negative 2x to the fifth a solution to the above equation? Let's see. Well, so we plug that in there, we get negative 10 x to the fifth over x. So that's going to give you, well, that's going to give you negative 10 x to the fourth. You take the derivative of negative 2x to the fifth, you get the same thing. So it is a solution to the above equation. And we can keep going. The sales in dollars SFC of a certain brand of stove after the company shows C commercial satisfies the following logistic equations. Okay, logistic equations. This one, logistic equations are interesting, right? Initial sales are 250,000, and how are we going to be able to do this? Let's see. So how we always do it is we find this in here, 20 million. And we know that the sales, when they're growing the fastest, are always going to be half of that, 10 million. And if you're wondering why, well, think about the fact that this right here is just S times 20 million minus S. And that is maximized when S is half of that 20 million. All right, you can test it out. You can test anything you want out, but that is how it works. S times something minus S. When it's going to be maximized, it's going to be that something over 2 every time, every single time. But that our answer is 10 million, and we can keep going. dy dx equals x plus 1 and f of 1 equals 2. Use Euler's method with 2 steps to approximate f of 3. This one I'm going to start writing stuff down. Right, so if you're unfamiliar with Euler's method, I'll show it to you. So how it works is you essentially just write x, y, and then dy dx. dy dx times, well, two steps of equal size. So you're starting at 1, you're going to 3. So each step is going to be 1. So just dy dx times 1, which is just dy dx. But sometimes if you have like a step size of like 0.5, you'll have to write that in or something. So you set up a table that looks like this. Right, table looks like that. Okay? Now x starts at 1. Y starts at 2. dy dx is x plus y. X plus y is 3. Alright, now I'm going to do x equals 2. And I'm going to add that 3 to the 2, the 3 dy dx that we got. I'm going to add that to the y coordinate. And I'm going to get 5 as our new approximate y. 2 plus 5, that's x plus y, that's going to be 7. So then for 3, I just put 7 plus the 5, and I get 12. Right, so this is what we did. Right, this is how Euler's method works. You find out what dy dx is, you add that back to y right here, and then you just keep going. And then you add it back to y. Right? And with 2 steps, we got 12. So our answer is 12. And we can keep going. The number of people using an older version of the spreadsheet program decreases at a rate that is proportional to any time to the number of people still using the version at that time. There were 10,000 people using the older version of the spreadsheet program when the new version first came out. The number of people still using the older version decreased by 20% every 6 months. How many people are still using the older version of the spreadsheet after 2 months? Well, it's going to be less. So it's definitely not going to be like 10,627 now. It decreases by 20% every 6 months. So decreasing by 20% every 6 months, it's definitely not going to decrease more than 20%, right? So we can't go to 5,848, so our answer has to be 9,283. Right, that is our answer. And we can keep going. What is the general solution? Oh, the differential equation that generated the slope field. This is interesting. So everything that's on the x or y axis is 0. So it's probably going to be like x times y or something, somewhere in there. Right? Or actually, this isn't even a dy dx. This is just x, finding x and y. So if x is anything, x can be literally anything. If x is 0, then y becomes a lot of things, doesn't it? So we're going to have to find the derivative here, right? If we want to really get anything done here. All right. So how are we going to do that? Well, we could either do that, or we could just take some random values and shove them in and see what we get. We can take 0, 0 does not fit. We can't even put 0, 0 in. Right? There's nothing for 0, 0. That's interesting. That's interesting. Right? Can't do that. So that's something to take note of. If you plug in 1 as x, if you plug in 1 for x, you get 0. If you plug in 1 for x and 0 for y, then this becomes vertical. Okay, so what do we think here? So we're going to start writing down some derivatives. The derivative for the first one is dy dx equals c e to the x minus 1. The second one is c to the x squared over 2, and then times x. So cx e to the x squared over 2. And the next one is going to be negative cx e negative x squared over 2. And the next one is going to be 2y dy dx minus 2x. So it's going to be, you add the 2x to both sides, and then you divide by 2y on both sides. And you get that dy dx equals x over y. That's interesting. That is very interesting. And then for the next one, you get, it's going to be negative x over y. So you have these 5 derivatives, right? A, B, C, D, E. And you just have to plug in some numbers and see what you get. The very first thing I notice is that for the first 3, if I have the same x, I don't care what I have for y, and it's going to give me the same thing. Let's look at a thing. If I keep the same x, like at x equals 1, and increase the y, it changes, meaning that you can't have these first 3. So none of the first 3 work. And you have x over y and negative x over y. Well, what do we see? In the first quadrant, right, where both of them are positive, you always are going to negative. The second quadrant, where there are different signs, so x over y should be negative, it's going positive. The third quadrant is going negative when they're both the same signs. Fourth quadrant is going positive when they're different signs, so it keeps switching. So it should be negative x over y, the last option, and we can move on to the next question. Alright, f prime of x equals negative 6 f of x, and f of 2 equals 1. Solve the equation. Let's see. Well, dy, essentially just saying that dy dx equals negative 6y. So dy over y equals negative 6 dx. So ln y is going to equal negative 6x plus e, which means that y is going to equal e to the negative 6 plus c, right? So plus c in the numerator, and not in the numerator, in the exponential. So it's just going to be like a at the beginning. So a e to the negative 6x. We use a to represent a constant that you're multiplying by. Usually it only pops up here. Alright, so the a, well, what do we know about that? Well, if we have y equals 1, that means that x is 0. So we have to plug in we have to plug in 2 in this, we get negative 12, e to the negative 12. So instead of putting an a at the here, if we put in a plus c in the exponential, then we could get e to the minus 6x plus 12. So when x is 2, e to the 0, y is 1, and that works. Our answer is e to the 12 minus 6x, and we can keep going. F prime of x equals negative 3x squared plus 2x plus 4, and f of 4 equals negative 20. Find f of 2. So we take the antiderivative, we get negative x cubed plus x squared plus 4x. If we plug in 4 into this, then we get negative 64 plus 16 plus 16, so that's negative 30. We have to add 12 to get to negative 20 that's the constant. Now we plug in 2, we get negative 8 plus 4 plus 8 plus 12. So the 8's are going to cancel, and you have 4 plus 12 is 16, and we can keep going. Puppy gains weight W at a rate approximately inversely proportional to its age t in months. So as t increases, dy dt goes down. So t is in the denominator. T is in the denominator, and then the k is a constant, so it can be anywhere. So t is the denominator. And that's our answer. Alright, so that is it for differential equations. I hope you enjoyed the video or learned something from it. And I'll see you next when we continue looking at more of AP Calculus topics. I'll see you then.